Alright, so today, first thing we're going to start talking about are percentiles and quartiles. So, percentiles and quartiles, we haven't actually heard that word yet before, but it's very similar to your percents, although a percentile, as soon as they add those last three letters of ILE to it, it then means that it's comparing you to some people. So a percentile tells us what percent of the total frequency scored below that measure. Percentile measures from the bottom. So the example I always use for percentile is when you guys are babies and you're born the first 2 or 3 years of your life, they track your height, your weight, and the measure of your head circumference, and they rank you against all of the other kids who were also born on the same exact day as you, and they give you a percentile ranking. So for example, right now with my daughter Madeline, the last time we were at the doctor's, her height was in the 47th percentile. So what that means is 47% of the kids born on the same day as her are shorter than she is. So she's in the 47th percentile. Her weight is in the 43rd percentile. So again, that means 43% of the kids born on the same day as her weigh less than she does. Now, since those scores are pretty close to your 50th percentile, they say she's about average. 50th is your average. Anywhere close around there, like in the 40s and the 60s, those are also considered to be around average. However, for her head circumference, she's in the 98th percentile. So 98% of the kids born on the same day as her have a head smaller than she does. So she's kind of got a big noggin on top of that little average sized body. So hopefully someday she grows into it. But actually we bought her a tricycle. The Easter Bunny got her a tricycle for Easter. And so the helmet that he got had to be, it was one for 5 to 8 year olds because her head is just so big she couldn't fit into a toddler helmet. So the percentile, she got a big head, full of brains. So percentile compares you to the people who are lower than your scores. So with her being in the 98th percentile, are there many kids that have a bigger head than she does? No, there's only about 2% of kids out there that have a head bigger than hers. So yeah, it is pretty funny. So then quartiles, those are the same thing as your percentiles, but all it does is it breaks it down into 4 equal parts. So quartiles are very specific. We have a 25th percentile, which is considered a quartile, your 50th, and then your 75th. So that breaks it down into 4 pieces of information, and I'll show you an example of it in our box plot down here. So you can actually calculate the quartiles by hand. What you have to do in order to do that is you would still arrange your data in order going from least to greatest. Then what you want to do is you want to find the middle of that data. So then the middle of that data would be your 50th percentile, which is your Q2, your second quartile. It is also your median, one of our words from last class. Median, second quartile, same exact thing. So once you get that number, you're going to take the first half of that data and find the middle of that one. And that is what we call your lower quartile, also known as your Q1. That's your 25th percentile. And then you would take the upper half, find the middle of that one, and that's your upper quartile, known as your Q3. So now another value we're asked for occasionally is your interquartile range. We also shorten that down into your IQR. All that is that's your Q3 minus your Q1. So once you get your first and your third quartile, subtract them. That's going to be your interquartile range. So down here we have an example of a box and whisker plot. Sometimes they shorten this down and they just call it a box plot. So this is an example of a box plot here. So there is a number line. So we got this number line right up here. Your box plot can never be touching your number line. It either needs to be below it or it can be above it. It can never be on the number line. Do not ask me why they're so picky, they just are. So with your box plot, the box itself is made by connecting your first quartile, your second quartile, and your third quartile. So you find those values first. That creates your box. Here's your minimum, and here's your maximum. So what ends up happening with your box plot is from here to your first quartile lies 25% of your data. From your Q1 to your Q2, that's another 25% of your data. Your Q2 to your Q3, that's another 25% of your data. And then your Q3 to your maximum, there's your last 25% of your data. So it gets broken down into your quarters, so then you can see it. And then what a lot of people do is you start analyzing it. Are they all approximately the same length? Or is one part of your box bigger than the other part of your box? And what does that mean? And all that kind of stuff. Now we do have some special cases. If you have an outlier, a lot of times they will remove it from the data set but then mark it with a little star or asterisk when you make your box plot. So then down here, I have all the steps you need to follow if you're making a box plot. I'm not going to sit here and read through them. We're going to actually make a box plot in a minute on the next page. But this is here for if you forget. So let's take a look at the next page. So now this is an example of a dot plot. So what they did is they took all of this information here and they created a scale and they just put the dots above for how many there were. So the fact that there's 1, 2, 3, 4, 5, 6 dots above the 5 tells you that there were 6 5s in the data set. So the dots tell you how many of that number there were. Notice the scale is consistent. It's always going up by 5s. If you had a scale where you went like 1, 2, 5, 7, that's not a consistent scale. You have to make sure your scale is consistent going all the way across. Can't have this. And another thing you always need for your dot plots is a title. So this one was dealing with low temperatures across the United States. So, down here, we're going to practice both a box and whisker plot and a dot plot. So we have a survey was taken amongst 12 people to find the number of passwords they have memorized. There are their answers. They want us to first create a dot box plot for this one.
What box plot?
Box plot. So, in order to create your box plot, you need to have what we call the 5-number summary. You must write those 5 numbers every single time you create your box plot. If you don't, you're going to lose points. And this kind of question has actually been on the Regents multiple times, so this is an easy couple of points for you to get. Just write your 5-number summary and then make your box plot. So what I want you to do right now, in your L1 on your calculator, type in our data points.
0.
0. Q1?
1.
Q2, also known as your median? Q3?
3.
And our max?
6.
So on our scale here, we could actually go up by ones. So I'll do 0, 1, 2, 3, 4, 5, 6, 8, 9. You want to try to spread it out as much as you can, but we didn't have enough lines to go like every other one. So I'm going to put a dot above all of our important numbers. I'm going to put a dot above my 0, above my 1, above my 2.5, above my 3.
Would 6 be an outlier?
It would not be an outlier, no. An outlier for this would be like 13. It's got to be really far away.
So it would probably be like double your max would be an outlier. Right?
Yeah, pretty close. So your box goes around your middle values, your Q1, your Q2, and your Q3. And then you just connect your max and your min to the box with a line. So there we go. We created our box plot for this data.
We need title.
Not on a box plot. Only on the dot plot. So if you want to get in the habit of putting a title, you're not going to lose points for that. So that's not a bad thing we could do. We could write number of passwords. It's a good habit to get into just so you don't forget to do it when you actually need to. So B, compute the IQR for the data set above. So your IQR is your Q3 minus your Q1. Basically, you're figuring out how big is the box part of your box plot that we just made. So that'd be 3 minus 1, which is 2. So what does this mean? That means the middle 50% of our data is around the number 2. Middle 50% of data is around 2. Which, if you look at our box, isn't the whole box around basically the number 2? Yeah, so that would be an accurate statement. Yep, so now we're going to create a dot plot for this data. So we're using the same numbers. So again, we have to create our scale. So this one I would go up by 1s. Now when you make your dot plot, you have to make sure your dots are all the same size and there's the same distance between them because they have to be able to line up. So like 0, I'm going to put 1 dot above my 0. I got to put 3 dots above my 1. So I have to make sure that first dot lines up with my dot from the 0 because that line, it has to be able to make a straight line that represents all of your 1s. So then I'm going to have 2 dots above my 2, 4 dots above my 3, and then 1 dot above my 4 and my 6. So again, you got to try to make them the same size so that when you look at it, like for example, this one up here, when you look at it, these ones aren't all scrunched down, making it look like it's the same size as another line. You have to be able to see distinctly how many dots are in that row. So what's the other thing I need on my box or my dot plot? Title. I'm going to call it number of passwords again because it's the same thing. For now, sure. Well, we didn't do D yet. Oh, you're going ahead. So your range, yeah, max minus your min. He was being funny. So what is the mean and standard deviation for the data? What can you say about the variation in the data? So let's look at our calculator. Your mean is that very first one. What's your X bar? Oh, we'll go 2.4, around at the 10th. And then our standard deviation, we have to remember, is this a sample or is that the full population? Sample, so we got to use the SX. So we'll go to the nearest 10th again. Was that Amina? 1.6. So then what can you say about the variation in this data since it has a standard deviation of 1.6?
It's closer together.
Closer together. It's not a lot of variability. Because they're the most.
Finally,
Describing the shape, center, and spread of a distribution. So these are, do you guys know what these kinds of graphs are called? Pretty sure you've seen them before. Histograms. They are bar graphs, but our official title is a histogram. We're going to be working a lot with histograms. So, with your histograms, in order to be able to tell the shape of it, what you want to do is you want to kind of draw a curve going around the bars. You want to be as close as you can to the bars. You can even touch them, that's okay. Don't do like some big, huge curve going all the way around the top of it. But you want to follow the bars. So then if we look at it, this first one, we call this symmetric because if you were to draw a line right down the middle, doesn't it look almost exactly the same on either side? So this is what we call symmetric data. We also call this a normal distribution. This is what we consider normal. And then that curve that we just drew around our histogram, they refer to that as a bell curve. That is a perfect bell curve because your data is symmetrical.
Where's the dot plot, right? Where's the box plot?
So with our box plot, we know that data is symmetric because each of the four pieces here look like they're the same exact size. So all 25% of the data, there's the same amount of points within it. So it's all the same size, nothing spread out more than the other one. So let's write ourselves a little note here. Same size. Other thing is right here in your middle, your Q2, also known as your median, is exactly in the middle. So now for our next one, skewed right. This one looks very similar to your symmetric, and it looks like all of your information would be here in the middle. However, you've got a few extra bars that are pulling your information over to the right. So what ends up happening is your mean should be in the middle, but because of this little tail here, it starts pulling your mean to the right. So that's why we say this is skewed right. So wherever your tail is, that's the direction in which your data is getting pulled, so it's skewed in that way. So if we look down here at our box plot, because this right side of the box is larger, that's how we know it's skewed to the right. You've got some extra data points, maybe even an outlier, that's pulling your information just enough over to the right so it makes it skewed right. It would be all in the middle and be symmetric except for those couple of little points or that outlier. So skewed left is the same thing, however, your information is on the left. The outlier or those extra few little data points are on the left side pulling your information to the left this time. The left side of that box is the larger one because you've got information pulling you to the left, otherwise it would be symmetric. So then our other two types, uniform, that's when the bars are pretty much exactly the same height every single time. So like for example, if you were working at McDonald's and you're trying to look at your histogram for French fry sales, wouldn't it pretty much be uniform? They're always selling French fries. There's never a dip in the amount of French fries that they sell from month to month. So that bar graph would be pretty uniform. And then our last one over here, this is our bimodal, because when you draw your curve, you get two peaks. Because, kind of like the name suggests, that means you generally have two modes. So let's take a look at our examples down here. So the best measure of center to use when your data is skewed is the mean, median, or mode. It's never your mode. If it's skewed, that means you most likely have an outlier. So which one was our best measure of center if you have an outlier? Median. Your mean is affected greatly if you have an outlier, so that's why we always go with your median in that case. So what I want you to do is take a minute, look at these four graphs down here, see if you can figure out whether it's symmetric, skewed right, skewed left, uniform, or bimodal. All right, so this first one, letter A, what was that one? Skewed left. We've got our tail over there on the left side, so it's skewing your data to the left. How about B? This one would be symmetric. You're not always going to get a symmetric that is absolutely perfect, but our data is definitely not skewed. It's all clumped together in one spot. It's as close to symmetric as we're going to get. Yes. How about for C? Uniform. All those bars are pretty much the same exact height. And then our last one, D, that would be skewed right. Very good.